Liquids, according to the particle model. I've drawn it here in the middle. Notice this little part of my diagram here is actually the shape of my container. I've got like a bit of a bowl and I've cut it in half. And I've got my water, and the water sinks down to the bottom and begins to start taking up the shape of that container on the bottom. So when you are drawing your particle models, particularly for a liquid, you may want to draw yourself a container of some kind and draw the particles full on down to the bottom and starting to fill up that shape of the inside of your container. So what's going on here? We know that the primary feature that makes liquids so special from the other states of matter is that they can be poured, and they usually take up the shape of their new container. Why is that? Well, we have these particles drawn quite close together, but can you see they're a bit random? They're not quite as neatly packed together in rows and things like that we had in solids. What's going on here is that for liquids, the particles are still really strongly attracted to each other, so they're not flying away, not like a gas does. But they can't really stay rigid like a solid. So they're somewhere in between where they have that movement and the attraction between the two, but the attraction is not so strong that they can't move. They can actually begin to start rolling and sliding over each other. And that rolling and sliding is what makes liquids behave the way they do. You can imagine like a heap of them, and they can just roll over each other and start filling the bottom of the container. Kind of like one of those ball pens that you may have played in when you were little. Just like them, they'll fall in and they'd roll and they start to peter themselves out and fill that shape. That's the defining feature. They have a defined volume as well, and that's because there's very little gaps between the particles for a liquid. They're still quite tightly packed together, just not neat and organized. So liquids are non-compressible because there's no gaps for them to really move into, but they don't fly away, not quite like a gas does. And with that said, I think that's everything. With that said, we're going to move on to gases next.